You know that feeling, right? That amazing rush when you first build something real with a modern framework.
Oh, yeah. Click, compile, boom. It works.
Exactly. The code runs, the server, well, it hums along, and suddenly this thing you pictured, it's just alive on your screen. It feels like pure magic.
It's like a superpower.
But totally, you feel like, okay, I'm a developer now.
Mm.
But then, well, then for a lot of us, you hit it, that kind of invisible wall.
Uh-huh. The moment things get tricky.
Right. The moment when just knowing how to build isn't quite enough and someone asks you the why.
Yeah, why that framework choice? Or how does it really handle data?
Or the trade-offs.
Yeah.
You know, why use it this way and not that way? And in those moments, the magic, it can kind of fade.
Replaced by that. Humbling silence. I've been there.
Me too.
Yeah.
So today we're diving deep into exactly this challenge, that really crucial shift from knowing how to knowing why. Our source is a really powerful perspective from Quan Nguyen, the founder of Skill Wanderer, in his article Beyond Frameworks, How Computer Science Fundamentals Forge the Complete Developer. It came out June 22, 2025.
Right, I read that one. It's really foundational for what Skill Wanderer is all about.
Exactly. It's more than just a blog post. It's like a roadmap designed to bridge that exact gap between, surface level tutorials and really getting it. True mastery.
Mm-hmm. Mm-hmm.
So our mission here is to unpack why understanding these foundational computer science principles isn't just like a nice extra. It's essential for every developer to move beyond just using the tools.
And actually grasping the principles underneath, the why.
Precisely. So, okay, we've all felt that initial framework magic. But let's unpack this. What happens when that magic just isn't enough?
Well, Quan's own story really hits this home. He talks about diving headfirst into a popular framework early on. He thought, this is it.
Right, the silver bullet.
Exactly. He could use it, make things happen, but then he gets this internship interview. And he said he was politely shown the door pretty quickly.
Ouch. Why?
Because he couldn't answer the deeper questions. Why did the framework work that way? How did it manage data efficiently? What were the fundamental trade-offs? He knew the spells.
But not the magic behind them.
Precisely. That was his first real glass ceiling.
Yeah.
And what's really interesting is Quan realized this wasn't just him. He saw this pattern everywhere.
In the community.
Yeah. Engineers with years of framework experience, still struggling or getting stuck as forever juniors.
Right, pigeonholed.
Because as soon as they stepped outside those familiar tutorials or basic CRE stuff, their problem solving just vanished. But then contrast that, he'd see someone maybe less than a year in, but with strong fundamentals.
And they're flying.
Picking up new stuff, debugging really complex issues, innovating, just fast, confident. And the difference, he really emphasizes this, it isn't about the time spent coding, it's about the depth of one's foundation.
So it sounds like Quan's really pushing for a fundamental mindset shift. From your viewpoint, what's the biggest change a developer needs to make to get beyond the how and really lock into the why?
It's exactly that mindset shift. Smashing through that ceiling by moving beyond the how of using tools and into the why of the principles they are built on.
Going from coder to engineer.
That's it. Becoming an engineer who designs solutions. And Quan says this whole transformation, it's powered by two key pillars from computer science: data structures and algorithms.
DSA.
Right, DSA.
Good.
And their underlying foundation, which is discrete mathematics.
Okay.
That's the bedrock. All modern tech, it's built on this stuff.
Okay, let's tackle that first pillar then. Data structures and algorithms.
Yeah.
DSA. Now, for some people listening, especially if you're self-taught, maybe that might sound, well, a bit academic.
Yeah, dusty lecture halls, right?
Kind of. So why bother? What's the actual real-world point of this academic stuff?
It's a fair question. And yeah, traditional CS degrees sometimes get criticized for maybe lacking the hands-on with the latest tech. It changes so fast.
True.
Quan points out that universities often focus on the evergreen theory because the ecosystem moves so quickly. He actually tells this story about an early mentor who did both, a university CS program and a practical boot camp at the same time, just to get both sides.
That's of both worlds.
Exactly. And his mentor's experience, it highlights this universal truth, something we really, really believe in at Skill Wanderer. You need both. Deep theory and practical application. You need the full picture.
Makes sense.
So for self-taught folks, embracing that theory, that's how you build the other half of the bridge. Become that complete developer.
That blend of theory and practice is key. Okay, but let's get specific. How does this, seemingly academic DSA stuff translate into actual tangible benefits for us developers, for the apps we build?
Okay, great question. Think of DSA as the blueprint for organizing information and processing it efficiently. Quan uses a really good analogy. Packing for a trip. If you just chuck everything into a suitcase, clothes, toiletries, shoes, all mixed up, that's like an unsorted list.
Chaos. Try finding socks later.
Exactly, especially when you're late for the flight. But if you use, say, packing cubes, organize things, that's like using a hash map or maybe a sorted array. You find stuff instantly.
Tell me about it. My laundry basket is definitely an unsorted linked list most days. So applying that kind of organization to our code, what's the real impact on performance, scalability?
Huge impact. It's the difference between an app that stays snappy with, say, 1,000 users and one that just grinds to a halt with only 100. It's about building robust, scalable solutions. Stuff that can actually handle the real world, not just a little demo project.
Building for growth, not just for now.
You got it.
Okay, so performance is one big thing. What else does knowing DSA change? How we use our tools solve problems.
It totally changes how you see the magic behind your frameworks.
Demystifying the magic.
Exactly. Quan says, the frameworks you love, they aren't actual magic. They're masterpieces of applied computer science.
Okay.
Like when you use a simple sort method on an array.
Yeah.
Easy, right?
Sure, one line.
But under the hood, there's a sophisticated algorithm doing the work. Maybe quicksort, maybe timsort, something smart.
Right. And I hear developers sometimes ask, well, why do I need to know quicksort is behind sort if it just works? That's a fair point, isn't it? If you just need the feature shipped.
It is fair on the surface. But knowing that deeper layer, it's about empowerment.
How so?
It gives you the power to debug those frameworks when they act weird, when they break in ways the docs don't cover. Because you understand the principles.
Okay. You're not just clicking buttons anymore.
Exactly. You're an informed practitioner. You can make better choices about which tool fits which problem because you get its underlying design, its strengths, its weaknesses. And understanding DSA gives you the toolkit for non-standard problems. Well, most tutorials teach standard stuff, right? A blog, a to-do list, basic CRUD, create, read, update, delete.
Yeah, the usual suspects.
But what if a client needs something really different? A recommendation engine.
Like on Amazon or Netflix.
Exactly. Or finding the shortest delivery route for a whole fleet of trucks. Or a social media feed with really complex filtering, real-time updates, trending stuff. These aren't just simple data in, data out problems.
Yeah, sounds way more complex than just showing a list of posts. So how does DSA help tackle those?
Because these are fundamentally data structures and algorithms problems. You need to think differently.
Oh.
You start thinking in terms of graphs for connections, heaps for priorities, tries for searching text fast, queues for managing background tasks.
Okay, so it unlocks different ways of thinking.
That's the key. Creative problem solving, innovation. Building stuff that goes way beyond the standard playbook. You're not limited by your framework anymore. You're designing solutions. And then there's seniority. Quan is very direct about this.
What does he say?
The path to seniority is paved with optimization. Simple as that.
Okay, so if you want to be senior...
You need to know how to optimize things. Seniority isn't just years clocked in. It's about impact.
Right.
Can you diagnose that performance bottleneck that's killing the system? Can you slash cloud costs? Can you refactor for massive scale?
And doing those things, that requires DSA and big O notation, right? That mathy way to measure how algorithms scale.
Absolutely impossible without them. You need a solid grasp of DSA and big O.
So for those listening, what does understanding big O actually let you do? Why is it powerful?
It gives you a precise language instead of just saying, this feels slow.
Which we've all done.
We all have. Instead, you can say, this function is ON2. That's why it struggles with big data sets. It moves you from guesswork
to a scientific understanding.
Exactly. Making informed decisions that actually impact the business.
Okay, that covers DSA. Now, the second pillar you mentioned, discrete mathematics. This one sounds maybe even more intimidating for self-taught folks.
Yeah.
It might be totally new.
It definitely can sound that way. Academic, scary.
Yeah. So can you break it down? What is discrete math?
Sure. Quan explains it nicely. Unlike calculus, which deals with smooth, continuous change.
Like slopes and curves.
Right. Discrete math deals with things that are distinct, separate, countable.
Like?
Items in a list, users in a database, nodes on a network, even the steps in an algorithm. Think countable things.
Got it. Separate units.
Exactly. It's basically the mathematics of the digital world, and it's deeply connected, intrinsically interrelated with data structures and algorithms. It provides the rules, the logic, the language to build and analyze them.
So it's like the grammar for the logic computers use. Where does this, abstract-sounding math actually pop up in our daily coding? Maybe without us even realizing it.
Oh, it's everywhere. Seriously, every single if statement you write,
Yeah.
every while loop, every complex database query, that's formal logic in action. Propositional logic, predicate logic, straight from discrete math.
Huh. Didn't think of it that way.
And anytime you filter a list or do a database join or find unique items between two sets of data.
Set theory.
Yep, straight up set theory.
So knowing these principles helps you write cleaner code,
Yeah.
less buggy code,
Yeah.
because you can reason about it better.
Precisely. You simplify complex conditions, you understand your data operations clearly. It's like seeing the underlying structure, the DNA of your code that maybe you were using intuitively but didn't fully grasp. And another huge one is graph theory.
Graphs again.
Yep. Quan points out every social network, mapping application, or network infrastructure is a graph. Think about it.
LinkedIn connections, Facebook friends.
Google Maps routes, internet infrastructure, it's all graphs. And the data structures we use, like trees and graphs, they're direct practical uses of graph theory principles.
Makes sense.
He even mentions that the Skill Wanderer community platform they're planning, at its core, it's going to be a graph of users, posts, and their connections, powered by these exact ideas.
That's really cool. So using the theory to build the platform itself, are there less obvious places graph theory shows up day to day?
Oh, yeah. Think about compilers or interpreters parsing your code. They often build an abstract syntax tree. That's a tree, a type of graph.
Right.
Or dependency management in build tools like Webpack or Maven. Those are dependency graphs. It's really woven into the fabric of software development. And then we circle back to Big O notation.
Our tool for measuring efficiency.
Right. How fast algorithms run, how much memory they use as input grows. That tool, born from discrete math, it uses concepts from combinatorics, recurrence relations.
Oh.
It gives us that precise way to say, okay, this approach is fast and it's going to stay fast as we scale. It's the language of performance analysis.
So discrete math isn't just theory for theory's sake. It's the foundation. It gives us the language, the framework to analyze, design, optimize.
Exactly. And one more crucial point from Quan. Fundamentals aren't just about today, they're about tomorrow.
Future-proofing.
Definitely. Think about AI and machine learning, the fields dominating tech right now.
Yeah, huge.
They are not magic. They are pure applied mathematics. Calculus, linear algebra, probability, and crucially, discrete math.
And Quan's walking that walk himself, right? He mentioned deepening his own math knowledge for data science and AI.
He is. It aligns perfectly with his plans to expand Skill Wanderer into those areas too.
So how critical are these math foundations if someone listening wants to pivot into AI or ML?
Honestly, non-negotiable. So many self-taught devs hit a massive wall trying to really get AML because they skipped the math.
They can use the libraries maybe, but
They can't truly understand why things work or troubleshoot effectively or innovate beyond just using pre-built models. You need that deep math. It's the language of these fields. It gives you the intuition.
okay, wow. That's a lot to take in. Data structures, algorithms, discrete math, it can feel pretty overwhelming, right?
For sure.
Understanding why it's important is one thing. Figuring out how to actually learn this stuff, fit it into your journey, that's another challenge.
Definitely.
So what's the plan? How do we actually start tackling this? Quan gives a pretty clear action plan, doesn't he, for the skill wanderer in all of us?
He does. 2 really crucial steps. Step 1, start a learning diary.
A diary. Like, Dear Diary, today I learned about linked lists.
Huh. Sort of, but more structured. It's about actively documenting your journey. Don't just watch videos or read articles. Write down what you learned, what you struggled with, which resources clicked, which didn't, what gaps you still see in your knowledge. Quan calls these notes a treasure.
Why a treasure?
For your own growth, looking back, and potentially for helping others later. It makes the learning active, not passive. It helps it stick. Then comes step 2. Apply it and teach it. He calls it the teach to master approach.
Okay, break that down. Apply it.
Get your hands dirty. Don't just read about a linked list. Write one from scratch in JavaScript, Python, whatever your language is.
A queue, a stack.
Exactly. Build them. Don't just copy-paste code. Really wrestle with it. He even suggests using AI like ChatGPT or Gemini to generate practice problems for you.
Oh, interesting use case.
Yeah, get it to give you something to solve or optimize.
Yeah.
And then key part, document your solutions, your struggles, your insights right there in your learning diary. Build that practical experience.
Okay, that's the apply part. Then teach it.
Right. Use those notes from your diary, the things you struggled with and figured out, and help someone else. Explain it.
So it's not just about being nice and giving back.
That's part of it, sure, and it's great. But Kwan says the real power is that you are actively patching the holes in your own understanding. Teaching is the ultimate test of your own mastery.
That really resonates. Have you found that to be true? That teaching solidifies your own understanding.
Oh, absolutely, 100%. There is nothing like trying to explain a concept clearly to someone else to instantly reveal where your understanding is fuzzy. I remember years back thinking I totally nailed recursion. Easy peasy.
Famous last words.
Totally. Then I tried to explain it to a junior dev I was mentoring, and suddenly I'm stumbling over explaining the base case, getting tangled up. It forced me to go back really deep in my grasp, find better analogies. Then I could explain it. It's humbling, but man, it works. And to kind of wrap up this action plan, Kwan brings in a fantastic quote from Ryan Dahl.
The creator of Node.js.
That's the one, Dahl said. You can never understand everything, but you should push yourself to understand the system.
I like that. Understand the system. I remember feeling totally paralyzed early in my career, thinking I had to grasp every single detail perfectly before I could build anything meaningful. What was your aha moment with that idea? Realizing understanding the system matters more than perfection on every tiny piece.
For me, it was probably debugging a really complex distributed system, microservices everywhere.
Oh yeah, fun times.
Right. I couldn't possibly know every line of code in every single service. Impossible. But by deeply understanding the principles, message queues, how distributed transactions worked or didn't, eventual consistency, understanding the system architecture,
You could find the problem.
much faster. It freed me from feeling like I needed total omniscience. Focus on the connections, the overall flow, the core principles. That was way more powerful.
That makes so much sense. Okay, so let's try and wrap this up. The big takeaway here seems to be learning CS fundamentals, DSA, discrete math. It's not some optional academic thing you can just skip.
Not if you want to grow, no.
It's the practical, necessary path. It's how you break through those career plateaus, gain real confidence to tackle hard problems, actually achieve seniority.
And future-proof your skills, especially with AI becoming so central.
Right. It's about becoming that complete developer, building with both the how and the critical why in mind.
And, you know, this whole deep dive really embodies that skill-wandering saga idea, that continuous growth journey that Skill Wanderer is all about supporting.
Absolutely.
In fact, Kwan mentioned a recent survey he ran in the Skill Wanderer community. Guess what the top choice for a new course was?
Let me guess. Algorithms.
Bingo. Algorithms and design patterns won by a decisive margin.
Wow. That really validates everything we've been talking about. People feel this need.
They really do. And the good news is, Skill Wanderer is listening. We're excited to confirm that a course on exactly this topic is in the works, designed to address this core need head-on.
That's fantastic news. So, a final thought for you, our listener. Reflecting on this, what aha moment came from a mistake you made recently? Some coding bug where maybe understanding a deeper principle could have saved you some pain.
Or thinking about that teach to master idea. What's one specific hole in your understanding right now? Something you're a bit fuzzy on. Could you try patching that hole by actively explaining it, maybe to a colleague, a friend, or even just writing a blog post about it this week?
Great challenge. And if you are ready to start that fundamentals journey or dive deeper with structured learning paths built around these ideas, definitely check out skill-wanderer.com. Explore how the platform is building courses designed to bridge that gap between theory and practice using the very roadmap we discussed today.